seems to me, love them or hate them, electric cars are in flux. They're not the surefire winner that everybody thought they were going to be, particularly when you read reports about how much they cost to maintain, that the fact that electricity prices are going up so high means they're not as cheap to run as everybody thought they would be. They don't retain the value, and the insurance is ridiculous. The infrastructure still isn't there, so charging them is an enormous problem. Whatever you think about that, whether you agree with that or disagree with it, I still think it indicates that electric cars are not the answer that we thought they were going to be. And in fact, Japan hates the electric car, or at least it's an argument that could be made that that is the case, because they're putting a lot of effort into hydrogen. And of course, hydrogen has its own problems. I mean, you're thinking about things like how it's made, how it's transported, and how it's stored being challenges for hydrogen cars. So what I've got here is some concentrated potassium hydroxide. It's 5 molar potassium hydroxide solution, and I've got a little bit of aluminium foil. Now if I drop that aluminium foil in there, we give it a little bit of time, the oxide will burn off and it will begin to bubble and fizz. Okay, so you should be able to see the fizzing around there around the aluminium, and if I push it down a little bit, there we go, it's going a little bit crazier. All of that is bubbles of hydrogen, and this is a chemical way of producing hydrogen. And as that gets going, it fizzes more and more, producing more hydrogen. Now this is called Uyeno's method, and it produces a particularly pure hydrogen. It also produces a potassium aluminate. So the potassium hydroxide and the aluminium are consumed, hydrogen is released, and potassium aluminate is dropped to the bottom, and that's what the reaction does. Now there's also a couple of other things. That not only do we get the production of the chemicals there and the hydrogen we might want in order to burn something off, there is also a current formed and heat. Okay, so what I've got here is a stainless steel pot with the same potassium hydroxide solution in it and a little piece of aluminium. The aluminium is clipped to a motor, and the other side of the pot is clipped to the motor as well. So the two electrodes are the sides of the pot and the aluminium. Now if I dip that aluminium in my potassium hydroxide solution and give that a chance to get going, there we go. We are now producing electrical energy, and it produces a fair amount of power actually, depending on the amount of surface area of aluminium that's exposed. The thickness of aluminium will give its duration, and of course the surface area of the corresponding electrode. Now at the same time as producing that electrical energy, it's also producing the hydrogen, and it produces a considerable amount of heat. There's only a couple of little drawbacks about it. One is the reaction product is obviously potassium aluminate, so it consumes both the aluminium and the potassium hydroxide, so you'd have to be continually refreshing it, because if you're refreshing it, then what you're doing is filling a tank. You'd have to have some method of emptying it, some method of collecting the hydrogen, which is not too difficult, some method of continually recharging it, that is chucking in more cans that are electrically connected so that you can actually connect the current out, and then handling concentrated potassium hydroxide solutions, because Uyeno's only works with concentrated potassium hydroxide solutions. Actually, they work with sodium hydroxide too. So there's a few problems with it, but as a springboard into an idea, I think it's really, really excellent. Now, there are quite a few patents kicking around, and there was a guy called Francois Cornish who came up with an adaptation of this that I thought was absolutely fascinating. It was patented in 1987. He did some work with BMW on it, so proof of concept and proving that the concept actually worked, and BMW ran a 2-litre car on it, he ran a motorcycle, and it came out of patent in 2004 for fee-related issues. So the patent is an expired patent, so it's actually sitting there ready for anybody to have a look at it should they want to look at it. And the patent number is US patent 4702894. Now the mechanical apparatus that he suggested looked like this, and there have been replication attempts at that, and here's one of a replication attempt. I find that exceedingly interesting because he used water. So that was a tank of water with a reel of aluminium wire. He passes a current through the aluminium wire, high voltage current, from which he gets a high voltage coil and distributor to spark that wire. That spark of the wire between that and a rotating drum knocks off all the aluminium oxide, heats up the aluminium tip and exposes fresh aluminium to the water. So the reaction product of that are aluminium oxide, which sinks to the bottom of the tank, and pure hydrogen, and that hydrogen can be drawn off. Now, the experiments that BMW did show that this actually works. What was claimed that on 20 litres of water and 1 kilogram of aluminium, your average 900 kilo car would run for something like 400 miles. Now, that does seem like a lot, but certainly BMW are very interested in it. It's just that the disposal of the aluminium oxide was a bit of an issue for them. The inventor actually just disappeared, but this idea came out again in 2005 with an Israeli-based company called Engenuity, and they did a funding round in 2007 to raise $2 million to carry this idea further, hoping to create steam and hydrogen to be able to run a vehicle. And of course they brought their own patent out on it, expanding it from just aluminium to aluminium and magnesium. But it also didn't go anywhere, which seems a real shame because it looks like the perfect system for a car, particularly for a hydrogen on demand car, because you're only using water and aluminium, and the waste products are either aluminium oxide or magnesium oxide in a pure form that is easy to recycle back into the metal. And at one time it had the support of a serious car manufacturer in terms of BMW. So why it's gone nowhere, I don't really know, but it does look like the perfect system to pick up and to be able to experiment with, maybe turning it into a home generation system, or maybe looking at it as an onboard hydrogen generator for a hydrogen on demand car, for which it would be a perfect solution. Anyway, I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.